In this quick video, we're going to look at a number of important and useful facts. In a previous video, we looked at the binomial point distribution function that the calculator has, and noticed that it could produce all of the probabilities for a discrete binomial probability. In this case, we were looking at maybe something like a 5-question test. Each question we had a 40% chance of getting the question right, and so this was the calculator gave us these values, that the probability of getting exactly 0 of them right would be this, exactly 1, exactly 2, exactly 3, exactly 4, exactly 5. We can represent this information in a relative frequency distribution table or a relative probability table. There's the exactly x, it's just been transferred over here to a particular table. Now here's a point that you should know, that given any probability distribution, whether it's a binomial one or not, given any probability distribution function, you can calculate the expected value or the mean of that probability in the following way. You could multiply x times its probability all the way across and then add all of those up. So the mean is going to be the sum. This will happen in any probability distribution. It'll be x, the sum of the x values, times the frequency for that particular x. Okay, that mean will work all the time. Now, another thing that I wanted to point out here is that, of course, this relative frequency distribution for a binomial distribution is plotted here, and notice that it kind of has that feeling of being a normal distribution. It's kind of piled up in the middle and trails out on each side, and in fact a binomial distribution under certain circumstances can be nicely approximated by a normal distribution. And here's the amazing thing. Although this rule works for any probability distribution, for a binomial distribution, let me write that down, for a binomial distribution, the amazing thing is this, that mu will be equal to n, in this case n was 5, times the probability of success. In this case it was 40%. Now that's amazing. I want you to compare both of those and do that calculation with this relative frequency table and this formula, and also do it here. Notice how easy it's going to be there. It's just going to be 5 times 0.4. Not only that, but the standard deviation of a binomial distribution can be found in the following way. It's going to be the square root of n times p times q. Now this only works for a binomial distribution. Okay, but when you have a binomial distribution, you can get mu estimated this way, and you can get the standard deviation estimated that way. And when you find the normal distribution with this mean and this standard deviation, it will come a very close approximation of this particular curve. It'll be a great approximation for the frequency histogram. Okay, in summary again, remember the calculator was able to calculate these values for us. A relative probability distribution table, the mean can always be found with this particular formula. In the special case, when you have a binomial distribution, the mean can be calculated by just n timesing the probability of success. In this case, that's going to be 5 times 0.4. That's going to be a 0.2. And the standard deviation can also be calculated very nicely by this formula. That happens in the special case when you've got a binomial distribution. Okay, that's the end of that video.